Well, let's begin. I want to apologize to the people out in the network because we have to do some technical business. The Naval Postgraduate School takes the rating of the faculty very seriously, and every course, every student rates the faculty. And unlike other universities, the school here pays attention to what the students think. So I need to know first, who is the ranking officer? Come on, who's the ranking officer?
04.
You?
September 94.
Who gets it? You?
I guess so.
Will 15 minutes be enough, sir? Will the last 15 minutes be enough?
Sure.
Okay, fine. Thank you. To the students, in filling it out, if you want to comment upon the fact that it was being broadcast, they would like to know your reactions to being in a broadcast class. So we get now down to business. Unreliable data. It has been my experience, as well as many other people, that the data you get is not as reliable as it's advertised. Now, this is a serious matter. Not only in simulations do you suppose you got the right data, and you haven't, but many other decisions which you want to make, the data is not accurate. And to bring the case across to you, I'll begin in the physical sciences where you think you know what it is, and I'll move on to where it's more clearly not very good. It's a very, very awkward point that we cannot depend upon data the way we're supposed to. Now let me start with life testing. How reliable is equipment? Well, when we were laying down the first voice cable across the Atlantic, we decided to put it down in vacuum tubes because transistors were too new to be trusted. And they wanted 20-year life. Now the expected cost of a failure, vacuum tube, solder joint, whatever you want, was roughly $1 million. What between the loss of revenue, sending the ship out, pulling the cable up, fixing it, and putting it back down again, $1 million was the estimate. Now, in fact, the cable was cut twice near shore by Russian trawlers, and officially it was an accident that they happened to catch it. But there was no trouble to fix it because near the shore we happened to have a boat there and it was fixed very rapidly. So the thing ran for 22 years until we disconnected it. By that time we had such better systems that it wasn't even worth running that cable. That tells you something about technological obsolescence. Well, now, I had at the time they were beginning a bunch of IBM equipment, including a statistical sorter, which was a very nice machine for doing statistical work. The vacuum tubes to go in were available about 18 months before the cable went down. And they were naturally trying to test which tubes would last 20 years. Well, I was very cooperative. I was not involved directly. I was cooperative in making machines available and doing this to facilitate, but I was not involved. But the one boss, because of my efforts to help him, offered to show me the testing upstairs, which was just walk up one floor and there was a whole attic filled with equipment, which was testing these vacuum tubes. And he showed me this and that. And finally, me being me, you know what a guy I am, I said to him, why should anyone believe that test equipment is as reliable as what you are testing? He gave some rather weak answers. I saw no reason why I should make him more uncomfortable. So I left it alone, but it stuck with me. Consider the problem of life testing. Something is very highly reliable. With what will you test? It's a very difficult problem. It won't go away. Now we have some tricks. One we use is based upon chemistry that most, but not all chemical reactions double in rate every 17 degrees centigrade that I raise it. So if I raise the thing 17 degrees, it goes ages twice as fast. 34 ages 4 times as fast. But there's a limit how far I can raise the temperature before I melt it. So we do use accelerated life testing by raising the temperature. We also can increase the voltage and hope that any resistances break down sooner. And we also can increase the frequency, hoping that if there are failures, the higher frequency will expose them earlier. But that's about the limit of what we can do to test a device given less than 18 months that will last 20 years. That's the problem you're going to face. More and more you want long-term, highly reliable equipment because there's so much of it. And because you want the latest stuff, there isn't time to do adequate life testing like they did. I first went to Bell Labs. We went at such a slow rate, there were years to test before you got in the field. It isn't so anymore. Even in transistors, from the time they invented it until we were really commercially producing them was almost 10 years of development to get to a technical stage. Now we would not tolerate a 10-year delay. We are too anxious to get new things in, and this is a problem I say everyone will face who's involved in using frontier work. How will you decide that this will last as long as it's supposed to? What can you do? I don't have an answer. I worried about it, and I suggest that you can carry on worrying. I've given up. Now there are other things you can do, and I once suggested to Bell Laboratories that they form a life testing group whose job was to prepare to test the next device we were going to invent. I had only a couple of weeks to suggest you what they could do. They never did it. They were so busy testing what they had now, they had no time to prepare for the next unknown invention. As a result, the old saying, there's never enough time to do it right, but there's always time to fix it. I think you're familiar with that fact, particularly in software. It's a very, very vexing problem which you will face the rest of your careers. Now let me turn to some very simple ones, simple stories. A friend of mine who was a statistician was working with a department in our West Street building, and he did not think the measurements being made were accurate enough, because those measurements are going to go into further design. Well, he told the department head, nonsense. My people are good people, and those meters have brass plates saying they're not good. Well, my friend came in one Monday morning. He said, I'm sorry, he said, going home on the train Friday night, I left my briefcase, lost all my information, lost all the data. There was nothing could do but the boss would remeasure them. Then he produced the old data and showed it. They were very inconsistent. It didn't improve his relations with the boss immediately, but it did save Bell Labs some trouble. You will be surprised how many people think that their people can measure accurately. Furthermore, the brass plate on the machine says it's that good. And the measurements are not that good at all. Nowhere near. My brother, who worked for Los Angeles Air Pollution for years, told me once, every new instrument we get, when we buy it, we first take it apart, we ourselves recalibrate it so we won't have trouble. We cannot trust the manufacturer to build the thing right and have it operated and calibrated correctly. It was just routine, automatically. Rebuild it because what is advertised is not the actual accuracy at all. Now, the same statistician friend of mine was once making a study of patterns of telephone calls for a big company. The phone calls went through an automatic central office, and that automatic central office not only recorded the phone, when it started, when it ended, so they could bill it, but was also recording for him what the calls were. So he's processing data, and one day he notices there is a call that lasted 3 minutes to a non-existent central office. How come? Now you can see where somebody might dial nonsense, but it isn't going to last 3 minutes. So he begins to look, and he finds out a large fraction of the calls are to non-existent central offices. The machine that placed the calls did not record correctly what the calls were. The fact that the machine records data does not mean the data is correct. You can't trust it. No way. Now, once I did a very large inventory study for Western Electric. It was for 18 months on about 100 items. And they had the withdrawals, the returns to inventory, the new purchases, all those records, just how it went. They wanted me to simulate various rules. Now, in inventory, there's 3 things you can do. The point which you reorder, how much you reorder, and how soon the reorder one gets into the bins to be available. Those are the 3 things you care about. And I was to simulate various rules in various places to see how inventory would have worked for those 18 months? Well, I ask immediately, how do I know those records you aren't withdrawing something when there was nothing in inventory? He said, well, we thought about that. We made some pseudo transactions. We fixed them all up so the data is consistent. I believed them. I went ahead and started studying, and somewhere along the way, I found further inconsistencies. I had to stop, go back, re-massage all the original data and get it really consistent, and then do all the calculation over again. From that one, I learned never believe that data is accurate. Always go through for consistency on the checks. Now, when I started doing that, I got a lot of flack because people wanted me to get the answer. I said, after I've checked it. And when I found various errors, they generally admitted that I was wise to first check the consistency of the data any way you can. Because almost any large bunch of data you got will have inconsistencies in it. Quite noticeable ones. It's a fact of life. Now, I was once instigated and later in an advisory position connected with a very, very large AT&T study, which we carried out in UNIVAC in New York City. I didn't carry the work, I only was advising. And I thought, well, since the data is coming from every operating company and every branch, I had better make sure the IBM cards are key punched correctly. So we made up some questionnaires and marked them, sent them out to each operating company, got them to key punch the cards, examined, they punched the cards in the right columns and everything else. If it wasn't, we sent them back. Oh, great. Hamming's a genius. So now the real study goes by. The cards come in not punched right. How come? Easy. When the small pilot job came into a big organization, it went to the specialty key punch group. And they did it. When the big job came in, the main bunch had to do it, which is a different bunch entirely. They had not understood the purpose for the pilot study. And all my cleverness was vitiated because I didn't stop and think that, of course, that's the way it was going to happen. So we had the bad data and had to cope with it in the large instead of getting it out of the way in the pilot study. So what do you think a pilot study is going to work? Be careful. It may not work. Now, how about basic scientific data? How good is basic scientific data? Well, I had a book, I still have it, National Bureau of Standards, in which they published the basic physical constants. I think there's 7 or 10 of them. The velocity of light, the charge of electron, Avogadro's number, and so on. And there are the numbers that are in your notes, the numbers with the probable errors. And 24 years later, there are new values with the new probable errors right on the same page. And the purpose is to show you how much in 24 years we've increased the accuracy. Well, I said to myself, if the new values are so accurate, let's suppose they're exactly the right answer, how bad were the probable errors? I calculated the average probable error was something above 5. Now, to be 1 sigma out, 68% are within 1 sigma, 95% within 2, and 5 sigma, forget it, you don't get out that far. But they were. These carefully measured public values, given Fermi values, were 5 sigma or more out on the average from the values. And these were the best physical constants they could do. Well, another 20 years passed, there's another study, and I fiddle around and get a comparable measure, not quite exactly the same, but comparable. And I find out now that the errors are about half as big. They're still about 2.5 times out the probable errors last announced. Therefore, I assert to you, almost all the numbers you were given with probable error, the probable error is much smaller than it should be. Now, how can that be? I'll tell you how it is. Stop and think of how you actually do experiments in a laboratory. You assemble equipment, it doesn't work. You fiddle around, and you finally get it working, and then you fix it up here, there, and yon, and now it's really working. And you're about ready to gather the data. What do? You fine-tune the equipment. How do you fine-tune the equipment? You do it by reproducibility. Now, reproducibility does not mean the right answer. It's the one with low variance. You make those measurements, you hand them to the statistician sees low variance, you set the thing for, and he announces that's the accuracy. Is it? No. You set the thing for getting low variance. You didn't set it for getting the right answer because you didn't know how. You didn't fine-tune it for the right answer, you fine-tuned it for low variance. That's the only thing you could do. Reproducibility is what you tuned for. That is one of the reasons why. The data you give to the statistician, he announces very accurate ones because the measurements were made under low variance conditions. That accounts for it partly. Now I want to offer you Hamming's rule. 90% of the time, the next independent measurement will be outside the 90% confidence limits, not inside. Now it's really exaggeration. If you pin me down, I'd probably use 85, but 90 sounds much better. It's about 85% of the time will be outside the 85% confidence limits, but we'll say 90. You can look anywhere you want. For example, I looked at some Hubble constants the other day. All the measurements, well, the Hubble constant is the rate of distance versus redshift. Estimating that slope of that line. Almost every one of the measurements lay outside of anybody else's probable error. They couldn't have been right. Almost every one of those probable errors were wildly wrong. They couldn't have been other than that. Now there's a bit of trouble with data. You fit the data to a model. Now I may, for example, say the height of people are normally distributed. But you know that wherever I put the mean for a normal distribution, there'll be some with negative heights. The model cannot represent in that detail. People don't come with negative heights. So there's errors in the model and there's errors in the measurement. In the beginning, the error in the model doesn't matter because your measurements are kind of bad. But as time goes on, as you polish up technique and other things and you get better measurements, the errors in the model loom bigger. But they tend not to be looked at. You tend to be so busy trying to get your equipment right, you don't notice that, well, that normal distribution was only approximation. So that's another source of error. The model itself that you're trying to fit has errors in it. And you get kind of strange results. Now, another experience I had was very fascinating. I was on the board of directors of a computer company, and we were going to shift from one model of computer to another. And the engineers delivered all kinds of careful estimates of how much it would cost, how much machine time here and moving there, and how much unemployment and so on. All kinds of very careful estimates were made. And then the salesman was asked, if we price it so much, how many can you sell? If we price it so much, and so on. And he gave some estimates of how many he thought he could sell for various prices. That was combined with a very accurate engineering estimate, and the whole was taken to have the reliability of the engineering estimate. But of course, it had this wildly intuitive guess. I'm not saying he was wrong, but this is what happens frequently. The old saying, you know, a chain is as strong as the weakest link. You will find again and again management will take very accurate estimates from some places, combine them with some wild guesses, and assume that the result is as accurate as the accurate measurements were rather than the weakest one. It's very common. Management doesn't want to admit this so bad, so they simply bend things. That's the way management is. Now I've talked about science and engineering, so you won't get so uppity and think you're so much better when I talk about economics. There's a book by Morgenstern, The Accuracy of Economic Observations, second edition, Princeton Press. Now Morgenstern was a professor of economics at Princeton. He's a highly regarded guy. In the book he has lots of ones. My favorite one is his measurement of gold flow. How much gold goes from England to France? How much do the English say went from England to France? And how much do the French say came from England? Some of those numbers can differ 2 to 1. One country says they shipped twice as much gold, the other one said they received. Now if you tell me you're shipping electronic gear to some third world nation and it comes in as medical gear, I am not surprised, because medical gear will be taxed differently and bribery does work, and so we admit it as medical gear and escapes some taxes. I can see how electronic gear becomes medical gear, but I can't see how gold can change from gold. Nevertheless, the figures are 2 to 1 at times. These are the official world figures of how much gold goes from one place to another. Now, if you can't get gold right, what do you think you can get right? Another one he cites is one time something 30-odd% or something like that of General Motors was owned by DuPont. When they calculated the total assets of the world, of our country, you could bet that money was counted twice. There's lots of things like that. Now, one I found for myself was very interesting. It's now, I guess, 20-odd years ago. The government changed the rule of how they're going to tax inventory. Most companies promptly changed the way they kept their inventory figures to get advantage of savings. I watched the Wall Street Journal very carefully to see if they ever mentioned, in studying what inventory was, they ever mentioned, well, the figures, of course, are based on the new law, not the old law. Never mentioned. But you see, inventory holdings are a basic thing for predicting the future. The belief is that when the companies increase inventory, they expect more sales. Otherwise, they wouldn't have done it. They increase because they expect sales to be there. When they don't expect sales, they decrease inventory because that's capital investment with no return. So they think that inventory holdings correlate very closely with the expectations of the manufacturers. But here is another effect entirely, because the amount of inventory reported was now different to escape taxes, but it was never mentioned. That introduces a topic that things are not what you think they are. They are constantly changing. A definition today is not a definition tomorrow. A yeoman in 1850 is not a yeoman now. The official law may not state anything different, but you know they're different things. In any long-term time series, what is being measured is often changing. Even the wheat data. The kind of wheat they raised in 1600, the kind of wheat we raise now is different. They measured by the bushels produced, but it's not the same product. So you see, anytime you make a study of long-time trends, you run into the changing definition, which often is not officially stated at all. It's just done. As I say, a yeoman is not a yeoman. He's something else after a while. He does different things. So you have a problem there of any long-term study in time will cause that kind of trouble. As one of my favorite examples, consider poverty. Poverty's had a changing definition. People who are below poverty level now are living better than some of the kings of England did not too long ago. Whenever we get more, the definition of poverty will be changed, so we always have enough people below poverty to keep the people in business. There is no hope of ever removing the poverty by the nature of the problem. The definition will be changed, and you can't get out of it very well. Now, I would suggest that even though time series change definitions, you can still use the sophisticated methods of signal analysis I gave you in digital filters to analyze time series to try and find out what is happening. You can measure this or that effect and see how over the years it's changed, how your capital investment has changed against other assets, how it's changed against the number of employees. And in your case, you can be sure that as time goes on, there are going to be fewer employees and more capital goods because robots in one form or another are remarkably economical. As I told you before, they don't have to have pensions, they don't have sick leave because their grandmother died, they don't have to have recreation, they don't have to have all kinds of things. They don't have union troubles. It's inevitable you'll have more capital investment in capital goods than you will in people as time goes on. But that trend might be interesting. You might say, well, where are we headed? What can I expect in the next 5 years? What are the general trends? Using signal processing to get rid of background noise will help you a lot to understand, in spite of the fact I'm telling you, the definitions change to some extent. Now, the forms of economic predictors change very slowly. Every once in a while you read that they finally put a new stock in Standard & Poor's or something else like that. But they do it reluctantly. What has happened fairly recently is that we have shifted from more people in manufacturing than in data processing. We're the other way now. Less than half the employed people are involved in making anything. In fact, excluding the military in this country, more people are involved in government than there are in all of manufacturing. We have changed enormously, but our indices and Washington, D.C. does not recognize this enormous change from a society which is producing goods to a society that is doing something else entirely. It's processing information. And that trend is going to go on. Institutions like people hate to change. And the people using the indices say, well, if I change what goes in the index, it won't be comparable. It's better to have an index which is comparable and wrong than have the right index which isn't comparable, which seems a strange argument, but that's roughly what they say. And so very slowly they change the content of various economic indices, and they lag behind the reality by a great many years sometimes. Now, if you add to this the fact that for most economic data is gathered for some other purpose, like the country census and so on, you must realize the economic data isn't very good. No way is it reliable. So, when you make a study, what do you got? What you have is what you see. Expert economists disagreeing completely as what's going to happen next. They haven't got accurate data, period. Now, there's another thing that Morgenstern mentioned which I found very fascinating. Normally, for favored customers, you give discounts. Now, these discounts are secret. You don't want somebody else to know that this guy is getting 15% and he's only getting 10%. Those discounts to favored customers are very, very carefully kept secret. What does the government think? The government has to think this being sold at cost instead of at a great discount, because that isn't going to be told them. Now, what happens in prosperity and depression is those discounts change enormously. But there's no allowance made for that. In economic indicators, nothing is ever said about that little fact, that the discount rates are changing. Therefore, the actual money changing hands for the goods is not what it appears to be. But it's a changing difference. It's not a fixed difference. Now, what can economists do? Not much. Some of them must know, although my own experience with economists is they do not want to discuss the question, is the data any good? Morgenstern points out that at the end of the war, when they were starting the economic aid, the Marshall Plan, some high representatives of various countries said, we will report the economic figures that we think will get us the most Marshall aid. And that's what they did. And that's the official figures you now have to work with. They weren't accurate. They were what the countries thought would give them most economic aid. Who pretends that the figures are correct? The Bank of England has been caught lying about its gold holdings. Not just a small amount, significant amounts. You can't trust the Bank of England for telling you the truth. Not by a lot. Well, let's go on about the business. If the data is no good and you want to collect it, what can you do? There is a first tendency to think to get accurate data, you'll do a 100% survey. I tell you, on a large survey, a 1% or a tenth of 1% survey done carefully will be more accurate than a whole 100% survey using the same amount of money. Now, it may strike you as strange, but it's true. The telephone companies long ago take a very, very small sample of all the telephone calls made and allocate the money to the various companies who provide the long-distance lines and this, that, the other service. When you call New York, you're likely to go through quite a different path the next time you call. Sometimes you may go up through Canada, sometimes you may go through Mexico, you may go any place. It's got to be allocated reasonably, and they take a very small sample. The airlines for a while tried 100% sample, but after a while they got the same realization. They take a very carefully drawn sample of a few flights, and from that they distribute the money among the operating companies. They don't do 100% accounting at all. It's far, far too expensive and far, far too inaccurate. So don't think the 100% of samples are good. Generally, they're bad. I'll say again, it's better to take a small sample accurately done than a big sample poorly done. Now, the third thing is coming up. There was a time when we wanted to know facts. How many this or that there were. How many lathes did we have in the shop? But more and more we're concerned with human attitudes. More and more people's opinions count in our society. More and more you must use verbal surveys. Well, they're not reliable. We've got evidence overwhelming. The order in which I ask the questions can control the answers. The person who asks the questions can affect the answers. All kinds of things. The very wording of a question can be made to affect the answer. And pollsters know this. If they want to poll to get something, they know how to word the question so they will get the kind of answer they want. And so you can have two pollsters giving you quite different answers to slightly different worded questions. They appear to be the same question, but a slight change in wording can do a lot. So if you're going to make a survey, you need to get not a statistician, but as somebody familiar with polls to know how to ask the questions unbiased, so you'll get an unbiased answer. Now, of course, you want a biased answer, you get one who knows how to do that too. But generally, I hope you want to find something near the truth. And it's very hard to get. Now, you think you could measure things easily? Nah, you can't. One night at dinner, I was sitting next to a very charming widow who lived right next door, and we were talking about exactly this point. And she said, I don't see why you can't measure things. I looked at her and said, how would you make an estimate of the amount of adultery on the Monterey Peninsula per year? Will you send out a questionnaire and believe it? Will you try following people? Is there any way you seriously think you can get anywhere near that number? It doesn't seem to be possible. I have no idea whether it's be 10% or 90%. It depends on whether you believe the poets, the playwrights, and the novelists, where you think adultery happened every afternoon, or if you look among your friends and you think, well, you know, it really isn't worth the trouble for most people. They're too busy. It doesn't happen that often. It depends on where you look. You get very, very different answers. I haven't any idea. Not at all. But I warn you about the difficulty of getting answers from social situations. I recently filled out a very long, important questionnaire, and I filled out as honestly as I could, and I wondered what would happen. It was important not to me, but important to the organization. And I realized we're going to get nonsense. When you have a distribution, two different groups of people in a distribution, and you average, you get nonsense. And the one I've used to you before. If you take men and women, adults, average, the average adult has one bosom and one testicle. You don't meet the average person. No way. You can average data when the data is somewhat homogeneous. When it is not homogeneous, you are looking for trouble. You will get nonsense things like the average American family has 2.6 children. No family has 2.6 children. You'll get all kinds of idiot things by the standard techniques. Now, if you think that economic data is bad, consider what social data is. Even worse. There aren't any decent figures in social science. You see it all over the place. You see right now you're going through an enormous change in what is good for you in food. It wasn't too long ago when some things were taboo, they were awful. Now they're welcome. They're changing what you should eat enormously. They're changing various other things, what's good and bad for you. They don't have any reality. The new ones announced, they may be more accurate or less accurate than the last one. You can't get the real data you want. Not easily. It's very, very hard. So when you do it, be careful. Now, I'm warning you, the last thing, I've got to quit. If you will watch what happens when top management sends out a survey, I'll tell you what happens. Those groups that think they'll rate well on the survey generally get the survey done. Those who don't think they'll rate so well, they set it aside. Now the deadline comes. Somebody at the bottom is asked to fill the damn questionnaires in as best they can, and they're shipped back in. That's the data you will get when you're ahead, unless something is done about it. That's the data which you have to use to make decisions. Unless you start saying, I am not going to put up with that nonsense, I'm going to do things so that is not being faked out like that. Because I don't know what those faked out data will raise, lower, or leave the result unchanged. I have no way of knowing. Nor will you. Until you do better than we've been done in the past, we have not done a good job. Well, I've given you a bunch of things. I could go on ad nauseum about how bad data is. You can think for yourself. But will you please look while you're still at the bottom? When I was on the board of directors, my presence affected the behavior of a bunch of people. They were doing what they thought would please me, but in fact, it made me very, very annoyed. But there wasn't anything I could say. You have only to look while you're still junior. What is the effect of an admiral on what's happening? Quite different, right? Well, when you are a higher ranking, your presence will affect what is happening. You will not be able to find out by direct observation what is going on. Your very presence will screw it. You can't find out. Well, you need to know. If you're responsible, you need to know, and I'm telling you more and more, it will be personality problems like morale and so on rather than how many guns you have. Guns are easy to count, but attitudes are harder. Those are things that are going to concern you more and more, so please think about the matter carefully, how you're going to do it. I'll leave it to you. Thank you.